In November 2023, Voyager 1 started sending gibberish. Not silence, not a weak signal. Gibberish, data that made no sense, numbers that corresponded to nothing real, readings that the engineers at NASA's Jet Propulsion Laboratory had never seen before from any spacecraft in the history of space exploration. And the problem was this: Voyager 1 is 24 billion kilometers from Earth. A signal traveling at the speed of light takes 22 hours and 35 minutes to reach it, and another 22 hours and 35 minutes to come back. Every single command NASA sent, every attempt to diagnose what was wrong, every adjustment, every test, required 45 hours of waiting before they knew if it worked. For 5 months, the most distant human-made object ever built sent corrupted data home, while the engineers who built it tried to figure out if they had lost it forever. The spacecraft was launched in 1977. It runs on technology that predates the personal computer. Its entire memory is smaller than a modern photograph, and it is currently traveling through interstellar space, beyond the solar system, beyond the boundary where the sun's influence ends, still functioning after 47 years. By the end of this video, you will understand exactly how Voyager 1 got to where it is, what it found along the way, what happened in 2023, and why what it carries with it may be the most important object humanity has ever built. In the late 1960s, a young engineer at NASA named Gary Flandreau discovered something that had never been noticed before. He was calculating planetary positions for future missions and found that in the late 1970s, the 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, would align in a configuration that occurs approximately once every 176 years. That alignment created a window. A spacecraft launched at exactly the right time could use each planet's gravity as a slingshot, approaching the planet, stealing a fraction of its orbital energy, and being accelerated outward toward the next target, without fuel, without engines firing, using nothing but the gravitational mechanics of the solar system itself. The mathematics were precise and unforgiving. The window opened in 1977. It would not open again until 2153. NASA had less than a decade to design, build, test, and launch 2 spacecraft capable of surviving the outer solar system. The mission was called the Grand Tour. They built Voyager. Voyager 1 launched on September 5, 1977. Voyager 2 launched 16 days earlier, but on a slower trajectory. Voyager 1 overtook it and has remained ahead ever since. The power system deserves a moment because it is the reason these spacecraft still function in 2024 while everything around them is absolute zero. Solar panels are useless beyond the asteroid belt. So the engineers chose radioisotope thermoelectric generators, devices that convert the heat from the radioactive decay of plutonium-238 into electricity. No moving parts, no maintenance. A slow, steady, predictable decline in output that was calculated from the beginning. The engineers in 1977 knew exactly how much power Voyager would have in 2024. They designed the systems around it. That is not luck. That is engineering so precise it extends across half a century. Voyager 1 reached Jupiter in March 1979. What it found there changed planetary science permanently and immediately. The atmosphere of Jupiter revealed itself as something entirely different at close range. The bands visible from Earth were the surface expression of a system of jet streams moving at different velocities, generating turbulence that created storms and structures that no terrestrial atmosphere produces. The Great Red Spot, a storm observed from Earth since the 1600s, was confirmed as a rotating vortex system wider than Earth, moving continuously for at minimum 350 years. But the discovery that none of the scientists anticipated came from a moon, Io. Before Voyager, the assumption was that moons in the outer solar system were geologically dead. Io was expected to be a cratered, frozen world. 8 days before closest approach, navigation engineer Linda Morabito was examining images and noticed something above Io's limb that should not have been there. An umbrella-shaped plume extending hundreds of kilometers above the surface. Io was erupting in the image. At the moment it was taken, Io has more active volcanoes than any other object in the solar system. The energy source is Jupiter's gravity, tidal flexing that heats the interior so intensely that the moon cannot solidify. Europa was the quieter revelation. The surface images showed something that looked like sea ice on Earth, cracked, refrozen, moved. The pattern of fractures was consistent with a surface floating on something liquid beneath it. If there is a liquid ocean under Europa's ice, and subsequent missions have made this essentially certain, then the question of life on Europa is not absurd. It is serious. It is a scientific question with a real answer that we have not yet obtained. Voyager 1 reached Saturn in November 1980. The rings revealed themselves as a system of thousands of individual ringlets, each with distinct density, composition, and orbital behavior. The architecture was more complex than any model had predicted. Small moons embedded within the ring system were confirmed to be actively shaping the rings around them through gravitational interactions. Then Voyager 1's trajectory changed. By design, the encounter with Titan sent Voyager 1 on a path that angled it out of the ecliptic plane, up and away from the flat disk where all the planets orbit. There would be no more planetary encounters. The mission would become something different. Distance. The record for the most distant human-made object is held by Voyager 1 and has been since 1998. It extends that record by approximately 1.5 million kilometers every day. While Voyager 1 departed, Voyager 2 continued the grand tour. Uranus in 1986, Neptune in 1989. The only close observations of either planet ever made. At Uranus, the magnetic field was discovered to be tilted 60 degrees from the rotational axis, a configuration that existing models could not explain. At Neptune, wind speeds exceeding 2,100 kilometers per hour were measured, the fastest winds of any planet in the solar system. And at Triton, geysers were detected. A moon colder than any other body yet visited was found to be geologically active. The solar system had repeatedly demonstrated that the assumption of dead, cold, geologically inactive outer worlds was wrong. Every time Voyager pointed its camera at something expected to be quiet, it found violence. On February 14, 1990, Voyager 1 was 6 billion kilometers from Earth. Astronomer Carl Sagan had been arguing for years that NASA should turn Voyager 1's camera back toward the inner solar system before the power to the camera was shut off permanently. The scientific value was zero. Photographing the planets from that distance would produce nothing new. But Sagan wanted the image for a different reason. NASA agreed. The camera turned. A mosaic of 60 frames was assembled, and in one of them, in a scattered band of light from the sun diffracting through the camera optics, there was a pale blue dot, 0.12 pixels across. That was Earth. Every human who ever lived, every war ever fought, every city ever built, every piece of music ever written, every person who ever looked up at the sky and wondered what was out there, contained in a point of light so small it barely registered on the image. The photograph has no scientific value. It tells us nothing about physics or chemistry or planetary formation. What it tells us is something that cannot be obtained from any data. We are small, and we are temporary, and the universe does not orient itself around our presence. And somehow, we built something small enough to fit in a room that traveled far enough to show us that. The solar system does not end at a clear boundary. It ends at a transition. The sun continuously emits a stream of charged particles called the solar wind. This wind extends outward in all directions, creating a bubble around the solar system called the heliosphere. At the boundary of this bubble, the heliopause, the solar wind pressure equals the pressure of the interstellar medium pressing inward from outside. Beyond the heliopause is interstellar space, the space between stars. No human-made object had ever crossed that boundary. On August 25, 2012, Voyager 1 crossed the heliopause. The instruments detected a sharp change in the density and temperature of the plasma surrounding the spacecraft. The solar wind particles dropped away and were replaced by the denser, cooler plasma of the interstellar medium. The magnetic field orientation changed. Voyager 1 was in interstellar space, not in another star system, not near any other object, simply in the space between, the space that constitutes the vast majority of the volume of the galaxy, the space that is almost perfectly empty and almost perfectly cold. Voyager 2 crossed the heliopause in November 2018. The measurements from both crossings revealed unexpected complexity. The heliopause was not the clean boundary that models predicted. There were fluctuations, magnetic field structures that did not fit existing models. The boundary between the solar system and the interstellar medium turned out to be stranger and more irregular than decades of theoretical work had suggested. That is the nature of what Voyager keeps doing. It keeps finding that the universe is more complicated than we thought, from a machine that predates the personal computer. In November 2023, something went wrong. The data Voyager 1 was transmitting became corrupted. The spacecraft was clearly receiving signals from Earth. It was responding. Its carrier signal was present. Its position and velocity were correct. But the science and engineering data it was sending back was garbled. Random numbers, impossible values, information that corresponded to nothing real. The flight control team at JPL began the process of diagnosing the problem. Every diagnostic required 45 hours of round-trip communication time. Send a command. Wait 22 hours and 35 minutes. Receive the response. Analyze it. Send the next command. Wait again. For 5 months, the team worked through every possibility. One chip in Voyager 1's flight data system, responsible for storing a portion of the software, had failed. The chip was producing corrupted output. The solution the team devised was this: divide the affected code into sections and store each section in a different part of the memory. Memory that was not corrupted, but that was not originally designed to hold that code. Then rewrite the code so that the sections, now distributed across different memory locations, would still function correctly when called in sequence. This required writing and testing new code for a computer architecture from 1977, transmitting it 24 billion kilometers, and waiting 45 hours per attempt to see if each step worked. On April 20th, 2024, Voyager 1 returned usable engineering data for the first time in 5 months. By June 2024, all 4 of Voyager 1's science instruments had been restored to full function. The spacecraft is still transmitting, still in interstellar space, still returning data about the environment beyond the solar system. From a machine that is older than the internet, fixed by a team on Earth that had to rediscover how to program a computer they had not worked on in decades, across a distance that light itself takes 22 hours to cross. Both Voyager spacecraft carry a golden record, a 12-inch gold-plated copper disc containing 115 images, greetings in 55 languages, sounds from Earth, wind, rain, surf, birds, a mother's first words to a newborn child, and 90 minutes of music from cultures across the planet. It was designed as an answer to a question that humans have been asking since the first time anyone looked at the night sky and wondered if something was looking back. If Voyager is ever found by something that can understand it, The golden record is humanity's introduction. Not a distress signal, an introduction. The power systems of both Voyager spacecraft are declining. Instruments are being shut down one by one to conserve what remains. Somewhere between 2025 and 2030, the power will no longer be sufficient to operate any science instruments. And then, there will be silence. But the spacecraft themselves will not stop. In approximately 40,000 years, Voyager 1 will pass within 1.7 light-years of a star in the constellation Camelopardalis. In 296,000 years, Voyager 2 will pass within 4.3 light-years of Sirius, the brightest star in Earth's night sky. They will simply drift through the interstellar medium, carrying their golden records for billions of years after the sun has consumed the Earth. In 1977, the engineers who built Voyager knew they would retire before it left the solar system. They built it anyway. The 2023 crisis was solved by engineers who were in some cases not born when Voyager launched. They learned to speak to a 47-year-old computer in a programming language that no longer exists in any current curriculum. They fixed it. Right now, Voyager 1 is moving away from Earth at 17 kilometers per second. The most distant object humanity has ever built is also the only object measuring the space between stars in real time. Subscribe to BrainDrop if this kind of content makes you think about things differently. And tell me in the comments, if you could add one thing to the golden record that the original team did not include, what would you choose?